In this video, we're going to examine the division law for logarithms. And again, the division law of logarithms is stated here. This is also on our formula sheet for pre-calculus 30. What you see here is if we have a log with a base a and the stuff has a division, this division can be separated into individual logs that are being subtracted with the numerator and denominator put in the difference. So just like the multiplication law of logs, where they could be separated to an addition, this one can be now separated, but since it's division, we look at it as a subtraction, because remember, the answer to a log is an exponent. So when we have exponents to the same base, we subtract exponents. So in essence, we're just subtracting two exponents here. So if we look at the first example, we have log base 10 of x divided by y. Clearly, we have a division of that stuff. So according to the multiplication law of the division law of logs, we can separate it into the difference of two separate logs, with the numerator going with the first log, denominator going with the second. So log base 10 of x over y can be expanded to be log base x minus log base y. The second example kind of leads us astray. Again, the tendency here would be to say, hey, I can just separate these two individual logs. In this case, this is not possible. The division law of logs actually relies on a division in that stuff. We have a subtraction going on, so that can't happen. And in essence, the only solution here to expand this is to say this cannot be expanded. There is no division going on. There's nothing we can do. It just stays as is. The next example, expand negative 5 log x over 3, does have the division. So that means this could be separated into a difference of two logs. So we're going to take this chunk here and we're going to separate it. So that would be log base 10 of x minus log base 10 of 3. But we've had this 5, negative 5, there as well. If I left my answer as it stands, this would be incorrect, because in the original equation, that negative 5 applied to this whole log term. We took that entire log term and broke it up into this. So the stuff in brackets or parentheses here equals log base x over 3. Now the negative 5 is applying to all of that. So now I have to distribute that negative 5 onto both of those log terms. So it'd be negative 5 log x, and then it would be a positive 5 log 3, because the negative times a negative would equal a positive. The next example, example 4, if you look at it closely again, we have a subtraction here. Don't get fooled by that. It's not a division, so that means this one simply, again, cannot be expanded. There is no division. There's nothing I can do there. I can't subtract these into individual log expressions. Example 5 now takes it a step different way. Here it's saying condense this, so make it to a single log if possible. I do have a subtraction of two logs with base 10, so that means I should be able to, if I'm looking at the division law of logs backwards, I should be able to take the stuff and actually divide it out. So this would simplify to log base 10 of 12 divided by 4. And if I look, I could simplify the stuff there. Would be log base 10 of 3. So log base 10 of 12 minus log base 10 of 4 equals log base 3. Example 6 asks us to condense these two separate logs. We can examine them and see that they both have a base 10. There is a subtraction between them, which means we could take their stuffs and divide them out, although these stuffs now are polynomials. So now we just say log base 10, the numerator would be x minus 1, the denominator would be x plus 2. This is a simplified expression. It's condensed. Now the tendency that I would see a lot of kids incorrectly do is say, okay, now there's an x on top and an x on the bottom. They cancel, and I'm left with log of negative 1/2. This is incorrect. We cannot cancel part of a binomial for part of another binomial. So our final answer simply is log base 10 of x minus 1 over x plus 2. Example 7 asks us to condense it again. We see a subtraction, so we should be thinking of a division law of logs. The base of both logs are 10, but they do have a common factor of a. So before I go and do the division law of logs, I should factor out that common factor of a. So I'd be left with a times the log of x minus the log of y. Now I have the subtraction in there again. I can condense those two logs into log base 10 of x over y, and the GCF of a is still available. So that is now condensed into one log. Go ahead and work on these questions on the next page for the division law of logs. Simplify as far as possible if you can. And for answers, look up this lesson on puremath30.com.